Hello. So in this video I'm going to address how to quickly graph the six basic shapes of the trig functions, and I call that sort of the quick and dirty method. Okay? Now to contrast that, what's not quick and dirty? Well, it would be to plot points. So for example, for all the angle measures that you know, that you're familiar with, go ahead and evaluate them for sine, cosine, tangent, cosecant, secant, cotangent, and come up with points that you can plot. So you can see here I've approximated, let's say, square root 2 over 2 with 0.71 you would plot. Over over pi over 4, up 0.71. Then over pi over 3, up 0.87, and so on and so forth until you plotted all the points for sine, right? All these, and then, connected them. So if you did that for each of the six trig functions, you'll, of course, generate the shapes of the six trig functions. But you don't really want to do that every time you want to graph. So what do we really do? Well, you have to commit some material to memory, right? So in your long-term memory, meaning it's in there very well, you would know that the basic shape for Sine X is this one right here, okay? And you know the period is 2 pi, meaning that once you go around the unit circle once, one revolution, you'll generate this shape. And essentially, what's happening is when you start at 0 and you rotate to pi over 2 like that on the unit circle, you generate this quarter. Then when you rotate from pi over 2 to pi, you're generating this portion. When you rotate from pi to 3 pi over 2, you generate this portion. And when you rotate from 3 pi over 2 to 2 pi, you generate this portion. Okay. So that's what we mean by that. So how do we do this kind of quickly? Knowing this, and knowing that essentially your period is 2 pi and you have significant events, meaning you're crossing an x-axis, or the axis, you have an intercept, you have a max or a min. You have significant events every quarter of the period, or in this case, 1/4 of the period. 2 pi is pi over 2. So that's why these are labeled that way. So what do? So essentially what you want to do is take your period, which is from 0 to 2 pi, and divide this into fourths. Okay? And of course, let's go ahead and put our y-axis values here. And so then, what you're going to do is follow this shape. So I start here, this point here is 0, 0. Then you go up, so you go over a quarter and up to the max, which is 1. Then you go over halfway, you're down at the axis. 3/4 of the way, you're at the min. And finally, all the way back at the axis. So there's your first wave or cycle, right here. And try to go ahead and make it nice and curved, not a V, So there's your first one. After that, you're basically taking every other distance of 2 pi and dividing into fourths. So here, if I divided that into fourths, I would really have to keep going. But what I would find is I'd have this, the beginning of a wave, right? So I come up to here, and so I'd have this. Right? And then I can do the same thing over here, divide this period into 4 parts. And say here, and I go up to 1, come back to the axis, go to the min, go back to the axis. So there's my other wave. So it's all repeated. It's like a little rubber stamp. You just keep doing this. And then over here, you'd have the second half of a sine wave. So you'd be here, coming up from the min, like that. Okay. So that's the sine wave, rather quickly. And of course, you should be able to label 0, 0. This is pi over 2, 1. This is pi, 0. This is 3 pi over 2, negative 1. And here, this is 2 pi, 0. All right, so you're labeling each of these points, what I call the quarter points. All right, so that's sine. Let's take a look at cosine. So again, in your long-term memory, you have this shape. And you know that once you go around the circle, right, from 0 to 2 pi, you will generate this shape, and each quarter of the way something significant is happening. So you want to divide your period into fourths. All right. So same thing here. Let me just go ahead and put in the negative one. You'll take your period, divide it into fourths. Okay. And then you want to go ahead and put your significant events. So you're starting here at the max. Then as you come down, the first quarter is the axis. Then the next quarter is down to the min. The next one is back to the axis. And then finally ending at the max. So here you go. Again, try to make it curved, right? Do the best you can. Okay, like that. So that's your first wave, cosine wave. Now let's continue. So we have here, and again this we would divide into fourths, and then here's half. So now we can just keep going and say, all right, I would start at the max, go to the axis, and then come down to the min. So here's the second part. Starting, so you've got half of a wave here. And then here would be a wave, so you start at the max. Let me go ahead and use the black. Come down to the axis, go to a min, come back to the axis, and go to the max. So you're just now connecting that kind of nicely. Like that, right? Okay. And then over here, same kind of thing, but you're dealing with the second part of the wave, all right? So that's a cosine wave. Let's look at tangent. So again, in your long-term memory, you know already that tangent has this shape and that it fits between vertical asymptotes and that the period is pi, okay? So what I do to know how to get started is I think to myself, okay, let me go ahead and find the vertical asymptotes. I know that tangent of an angle is, and you could put theta if that makes you a little more comfortable, but tangent is defined as y over x, the y coordinate over the x coordinate for that particular angle, okay? Which means that when the denominator is 0, or when x is 0, that's when you create a vertical asymptote, okay? So then you have to say to yourself, okay, on the unit circle, there's my unit circle, where is it that the x coordinate, remember an x coordinate is motion, you know, left or right from the origin, where is it that that's 0? Well, it's here and here, at pi over 2 and at 3 pi over 2. Because remember, that's 0, 1, 0, negative 1, right? So there's your x right there. So you know that you should be putting asymptotes then at every multiple of pi over 2. So here's your pi over 2, right? 3 pi over 2, 5 pi over 2, negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, right? And so you're putting in your asymptotes. It's kind of relaxing. All right. Then, knowing your shape, you know that a dead center is where your graph is going to cross the axis, right? So you're going to have put this shape in there. And I could do a little bit better. Usually it's a little bit more like that, meaning it's not so tall and skinny. It does actually spread out here a little bit. All right. There you go. And so you just practice that a little bit. Okay. So on this side you have the second half of one here. And, well, actually that's, yeah, well, I don't know how we want to call it, first half or second half. All right. So here's where you would hit the axes, right? Right dead center in the middle. All the multiples. Oops, that's the vertical asymptote. Okay, that wasn't anything. All right, so that's tangent. All right, let's take a look at cotangent. So for cotangent, again, you have to have this committed to memory, this basic shape. And you know that you've got to find your vertical asymptotes, and you know right in dead center, this shape is going to cross the axis, and you know the period is pi. So again, I think to myself, okay, let me think about the definition of cotangent. I know that cotangent of an angle, let's go ahead and use, we'll still use x because that's what we're graphing here, but this x means an angle. That's defined as x over y, so your vertical asymptotes occur when y is 0. So then you think to yourself, okay, here's my unit circle. Where is it that y, the y coordinate, right? This is the x coordinate over the y coordinate representing the lengths of the triangle, reference triangle and all that. So where is it that y is 0? Well, it's here and here. And 0, pi, 2 pi, all multiples of pi, right? So now let's go ahead and put our asymptotes in. So Now I know that dead center in the middle, which would be all the multiples of the pi over 2's, that's where this shape is going to cross the axis. And so again, you just kind of bring in that shape and make sure it's curved, right? Give it some nice shape. There. And you can see the period is pi because take a look at the distance between the vertical asymptotes, right? It's the distance of pi. And again, your graph should never cross or touch the vertical asymptote. All right, so that's cotangent. Let's take a look at secant. So the basic shape for secant is this right here, sort of like alternating U's, and the low point of the one that's opening upward is y equal 1, and the high point in the y direction of the one turning downward is -1. So again, you want to find your asymptotes. So what you want to think of is the definition of secant. So secant of an angle is defined as r over x. So your vertical asymptotes occur when x is 0. Right? So again, you think, aha, here's my unit circle. Where is it that the x coordinate, moving like that, is 0? That would be here and here. So it multiples of pi over 2. Right? So you want to put in your asymptotes, right? So you can put in here. So that's pi over 2, 3 pi over 2, 5 pi over 2, right? So you're putting them in here. Negative pi over 2, negative 3 pi over 2, negative 5 pi over 2. So on and so forth. Now the period of this is 2 pi because it takes pi to do this and pi to do that. Okay. So now what you want to think is, okay, how do I know where it opens upward? For example, is this in here opening upward or downward? So to help us out, what you can do is draw the secant. The reciprocal of the secant is cosine, so you can kind of draw an imaginary cosine, and you know at 0, cosine starts out here at 1. So let me put here 1, and here -1. So in essence, you can kind of draw yourself a little cosine function, right? Like this. Just to help you out if you need to, right? Like that. And then you say, okay, now I know that the secant function, it rides the highs and lows of the cosine function, of its reciprocal function. So here you go. So you bring this in, right? And again, here's where your min would be for that. Now this one is going to be alternating. So again, it's going to ride this. So I'm just going to basically keep alternating at this point. But as soon as you know where 1 is, you kind of know where all of them are, right? So here you go. And then over here, and over here, so that right there, right? And finally over here. Okay, so there's your secant function. Last one, the cosecant, is very similar to the secant. Same kind of basic shape, same period, same process. So you want to think about, what is the definition of cosecant? So cosecant of an angle is r over y. So again, your vertical asymptotes will occur when y equals 0. So you think, okay, where is it on the unit circle that the y, like this, is 0? And it's all of these. It's 0, pi, 2 pi. It's all multiples of pi. So you say, okay, here's my vertical asymptotes. Let's go ahead and draw them in. So of course you draw them as dashed lines. And then here we want to go ahead and put in 1 and -1. And now, remember, you're going to ride, the alternating u's are going to ride the reciprocal function sine. So if you remember sine, then, right, you had here, right, divide this into fourth, and you're like, okay, here, coming up, go back down, go in, come back up. So you're like, aha! Now I can go ahead and put my u's exactly where they're supposed to be. Right, this is going to be like this, and then like this, and then like this, right, until you And of course, it's understood to go on forever and ever. I'm only showing you a piece, but you can see, like if you had a little rubber stamp for one part, the rest would go on exactly the same, right? Same shape. Okay, there's your cosecant function. Thanks so much for listening.